for adding and subtracting things, you have to, the same rules are in effect, and those rules are you can't add or subtract things unless they're like terms. I would say a root 48 and a root 27, they are not alike. So the first step for these is always to start by simplifying these radicals as much as possible. Since these are simple square roots, we can kind of go back to our trick of trying to find the biggest perfect square that goes into both of these numbers. So I know that 48 can be broken down into 16 times 3, and 27 can be 9 times 3. And we're going to treat this now like two separate problems, and even within these two separate problems, I have like more steps to break down. So let's do this. 5 is going to stay 5. The square root of 16 I know is 4. The root 3 is trapped. So this left side becomes 20 root 3. And then what about this? Why don't you pause the video for a second, see if you can do this yourself, the same way I did this. And now what I hope you see is that we have negative 2 times the square root of 9 is 3. That 3 is stuck in the square root symbol, so we have minus 6 root 3. Now these are like terms. They both have a root 3 on them. And it's kind of funny, but like root 3 is in some ways like an unknown. I don't know exactly what the number, what number square root of 3 is. I know it's somewhere between 1 and 2, but it's unknown. So this unknown and this unknown are similar. So these are like terms. And now what I'm going to do is treat this the same way I would treat 20x minus 6x. I'm doing the exact same type of thing, except instead of x's, it's root 3's. So the answer here will be 14 square roots of 3. And that's basically how you do it. I mean, the big trick is that these radicals have to match. And then you treat, once they're matching, you can kind of look at the problem as if it looked like this. And whatever you do here, you do the same thing, but you're using root 3 instead.